Our next pattern is famously known as the difference of cubes. This is a pattern that we have not seen before, so I'm going to actually go back to multiplication to build it, and then we'll end up using it. But the difference of cubes, as the name suggests, we have a difference or we have a subtraction, and both terms are basically being cubed. So a cubed minus b cubed. So I have, down here I have 4 different binomials. They actually do fit the pattern, and we'll investigate that a little later. Maybe some of you can already kind of see they're all differences, and each term is basically something cubed. And so difference of cubes. But let's go back to multiplication. So let's walk it a little bit back. And let me go ahead and show you the pattern. All right, it turns out that if I take a binomial, a minus b, and I multiply it to a trinomial, a squared plus ab plus b squared, this product creates the difference of squares pattern. And just to take a closer look, notice that the 2 terms in the binomial, they basically help create the terms in the trinomial. The first term is squared, the second term is squared, and their product is in the middle. That's how I kind of keep repeating myself to that. So first term squared, second term squared, product in the middle. Where we have a difference, so the binomial is a difference, and then everything in the trinomial is a sum. All right, so let's go ahead and see that and work. So to multiply, remember we just go term by term. So I first multiply the a, right, and make sure it hits all the terms over there as I distribute it. So that's going to give me an a cubed, right, plus an a squared b plus an ab squared, right? So a cubed multiplied by a and a squared b multiply ab squared. So that exhausts the a. Now we have to do the same thing with the negative b. So when I multiply here, I get a negative a squared b, and yes, I'm using the commutative property to rewrite. Multiplying to here, I get a negative a b squared, and then the very last, we get a negative b cubed. All right, and so there's basically the multiplication. And when we look real closely, we notice that here's a positive a squared b, and here's a minus a squared b. So those 2 terms cancel each other out. And then there's a positive ab squared and a negative ab squared. So those 2 terms basically cancel out. All right, and so what's left is the difference of cubes. So there's basically the breakdown, right? So what we just did is multiplication. If we were to ask to factor it, there's the factorization. So this binomial, that's the difference of cubes, breaks up into this bi times this tri, where the first term squared, last term squared, product in the middle. We match the sign, and then everything's addition. And just to kind of show that pattern again, this guy right here determines everything. So if I had, let's say, something like 2x minus 5, all right, then what's in that trinomial here is it's the first term squared, it's the last term squared, we're going to add their product in the middle. And I got too close, there's a plus sign there. So 2x minus 5, 4x squared, plus 10x, plus 25. All right, and if we FOIL this out, what we are going to get is 2x cubed minus 5 cubed, which is 8x cubed minus 125. So let's go ahead and do the multiplication to see that what I'm telling you is a true statement. So when I FOIL this out, right, that times that gives us an 8x cubed. 2x times 25 is a 50x, right? Oops, and then I forgot that term. 2x times 10x, right? That's 20x squared, and then a 50x. I'm getting ahead of myself. Doing the negative 5, we get a negative 20x squared. We get a negative 50x, and then a negative times a positive, and there's my 125. That term cancels out, that term cancels out, that term cancels out, that term cancels out, and lo and behold, we get what I said we would get. All right, so there's basically the pattern. So again, I'm kind of approaching it right now. We're multiplying, And what we're going to be doing is reversing that. If I notice I have the difference of cubes, I determine what two terms are being cubed. That helps me figure out what A and B are, and then I just literally plug them into our formula, our difference of cubes formula. Alright, so there's the difference of cubes formula. Unfortunately, it's the only way to factor the difference of cubes, so it's something you probably should memorize. In this online environment, you probably will just break it out on a note card, but I'm pretty sure your instructors in a calculus class one day, when we're back into a regular mode of teaching, they'll probably want you to memorize that. Alright, so let's get to work. So again, I have a binomial, right? It's a difference, and I see a cube. So immediately I'm thinking, okay, this fits, almost fits the difference of cubes. Clearly, right, there's something being cubed there, and then 8 we know to be 2 cubed. So this is truly the difference of cubes pattern. So A is x and B is 2. So let me go ahead and rewrite the pattern here. So we know the pattern to be that. So all I got to do is replace the A with x and replace the B with 2, and I've got it factored. So this would be x squared. If I multiply them together, I get 2x, and then 2 squared, it gives us 4. Alright, and so there is basically the product, the factorization of that binomial. Of course, the way you can check we're right is to multiply that back out. Alright, and I'll let you do that at home. But that's, again, that's kind of the beauty of factoring. You can always check your answer by just remultiplying it back together. We're going in a full loop here. Alright, so there's our factorization with the difference of cubes. Next example, again, I see a binomial, I see a difference, and I see a cube. So is this the pattern? Well, we just need to figure out what term is being cubed here. And out front there, we have the base is 2x, and it is being raised to the third power. So far, so good. 27, right? Well, that is 3 cubed. So we truly have the difference of 2 cubes. So here's your A, and here's your B. So let me rewrite the pattern, because all we're going to do to factor it is replace my A's and B's with what they are for this particular example. So A is 2x and B is 3. When I take 2x and square it, I get 4x squared. When I multiply 2x and 3, I get 6x. And when I take 3 and I square it, I get 9. And so there's your factorization. This binomial times this trinomial results in that difference of cubes. And so we factored it using our pattern. Alright, so hopefully you're getting the hang of it. Next example, again, I have a binomial. It's a difference. So can I rewrite the terms as perfect cubes? That guy is 4x cubed, and then 1, it doesn't really matter what I raise it to, right? Square it, cube it, fourth power, whatever you want to do. That's 1 cubed is 1. So it is the pattern, difference of cubes. So there's my A and there's my B, and then so basically I'm going to see if I can get away with just writing it. So I replace the A with 4x, I replace the B with 1. So you get 4x minus 1. If I square 4x, I get 16x squared. If I multiply them together, I get a positive 4x, and then 1 squared is 1. And so there would be our factorization of that binomial. Again, if you need to, I tried getting away with that without having to write the formula. It's over here. But if you need to see the formula and literally plug things in, please do so. Okay? And then last but not least, we got lots of things going on here, but it's a binomial. It's a difference. Can I rewrite that? And that is something cubed. If I can, if it's the pattern, we factor it. And so I believe this first one is 5x cubed minus this next one is 2y cubed. So it definitely fits the pattern, the difference of 2 cubes. And there's your A and there's your B. I'm going to go ahead and write the formula since there's so much going on here. So all I got to do is throw in these expressions for A and B. So A is 5x and B is 2y. So 5x minus 2y. What goes in these parentheses, or we're going to take whatever A is and square it. So 5x squared is 25x squared. Add, we're going to take A and B and multiply them together. So 5x times 2y is 10xy. And then last but not least, we're going to take whatever B is and square it. So 2y squared is 4y squared. And there's our factorization. All right, so that we have a new pattern. We have two of them so far, difference of squares and difference of cubes. We identify if we have the pattern, and as soon as I do it, we use the formula to basically throw things in, and we're factored. Last thought, the trinomial degree 2 here, you'll notice that I've never spent the time to factor it, and the reason being is it doesn't factor. You can try your guess and check routine, you can try your AC routine, right? That polynomial is a prime polynomial, so don't try to factor that trinomial. The difference of squares basically is that pattern. All right, we'll take a look at our last pattern in the next video.